All right, everyone. It's about that time. We're ready to start our third session of the Global AI Bootcamp. And for session three, it's going to be Jeff Palermo, and he's going to be presenting on .NET AI architecture and DevOps. Jeff joins us from the Austin, Texas area. He is the chief architect for Clear Measure, a software architecture company. He's been recognized as Microsoft MVP for many years, specifically since 2006, spoken at various national conferences, runs various user groups, and overall very active in the user group community, not just in Austin, but also all around. He has spoken at the Azure Cleveland user group multiple times. He's also a multi-time author and overall a great guy, quite honestly, and a great speaker. So very happy to have you. Thank you for joining us, Jeff.
Oh, thank you very much. Thank you very much. Glad to be here and excited about this topic. Uh, so this topic is .NET AI architecture and DevOps. And since roughly around 2022, the whole world and certainly the developer community has been enamored with ChatGPT as the showcase of what the GPT, the generative pre-trained transformer technology can do for us. And certainly there's a lot of fun things that it can do for us. For instance, with my kids and friends of their kids, it's a hoot to go to suno.com and literally generate full songs with beats and instruments and lyrics and have your own song just by putting in some input and tweaking lyrics and things like that, and generating images and rearranging text. And it certainly helps me with writing. It helps me run the Azure and DevOps podcast because I pull a lot of information for the bio of a guest that I would have on, and then I just throw that stuff into Windows Copilot because it's easy now. It's right on our desktop, and I quote it and I just say reword in third person, and it gives me all those details perfectly. I would have written it that way too, but if I need to introduce the guest, it needs to be in the third person, you know. And a lot of the bio information that I pull from various websites, it's in the first person or mixed. So there's so many advances, but what I want to talk about is how that impacts our .NET applications, what the architecture is, how to think about that, and how it modifies our process for designing, developing, um, validating, and then shipping and running and monitoring uh, software that is not only uses the GPT Gen AI technology, but is also used to develop it. So I'm going to go into both of those, but I really want to help you think in the right way. And it's anybody's guess what the technology is going to be 2, 3 years from now. Because remember, ChatGPT came out in 2022. That's between 2 and 3 years ago, and things are a lot has happened in the last 2 to 3 years, and so we have to expect that so much more is going to happen in the next 2 to 3. So regardless of what is available exactly right now, we can bet that a year from now, 2 years from now, and beyond, there's going to be extra ground that's broken. That's pretty much a guarantee. Um, the uh, the company is Clear Measure, and we're a full service software architecture and engineering firm, and our customer base are those using .NET technologies. And so we're putting all of this to use in all of the client projects to not only make cool software, but also use AI-driven development to dramatically shrink down delivery times, which is super important to top executives and CFOs and just level of investment. So the agenda for this talk, we're gonna demystify large language models and generative AI, what the heck that is. We're going to talk about the concept of AI-driven development. I have heard some people use the term prompt-driven development. That doesn't seem to roll off the tongue. Uh, and then we'll talk about the architecture for LLM integration with your .NET applications, and then we'll go through what changes in the DevOps environment for AI-enabled systems. Just last December, I put out my 5th book, and you can take a screenshot of the QR code, or you can just go to clearmeasure.com. If you'd like a free electronic copy of the book, just go to Clearmeasure and request it, or you can go to Amazon. It's also Audible, audiobook on Audible, and it's on software leadership. Just wanted to show you that. All right, so let's demystify this current generation of artificial intelligence. Back in 1956, at Dartmouth College up in the Northeast, there was a gentleman named John McCarthy, and he made a pitch for a little bit of summer funding for a program at the university to do a little research project. And his pitch, he had a hypothesis, what he wanted to research, and he defined artificial intelligence, and he defined it as the conjuncture that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. All right. So fast forward, how many aspects of human intelligence have been turned into a machine that can simulate it? And again, it's not a machine that can actually do it, but a machine to simulate it, being a machine to fake it, where the machine's doing it, and we look at it like, wow, is that machine intelligent? Well, we know it's not, but it sure is simulating it. Even so many of the modern cars, we don't call the cars AI cruise control, but the adaptive cruise control feature certainly is an aspect of human intelligence. Look ahead, see if there's a car coming, or if a car switches lanes in front of us really quick and now we're too close to the car, back off. Or I have plenty of space up front. Okay, press on the accelerator a little bit. That cruise control used to be pretty dumb, where you could cruise control your way right into the back of the other car in front of you. But now adaptive cruise control, guess what? There's a little machine, a computer, an automated bit of code that is simulating what previously had to be done by a human. So this is just in the long line of automation. And back in the 90s, there was a lot of hype around artificial intelligence. If you like doing that, you can just go and search for old magazine articles or conference talks, and you can see a lot of people were publishing and talking on artificial intelligence in the 90s. And there were 2 categories in the 90s. One was expert systems, and the other was neural networks. And just now, with our GPT wave of technology, the research into neural networks has finally come through. But back in the 90s, we did not have the computer hardware to really make progress on this concept of neural networks. Whereas the every large language model has that neural network research kind of embedded into it, and so it finally came to root. But expert systems did take off, and expert systems became a thing, and now we don't even call them expert systems anymore. We just call them business applications. An expert system is a software system that helps a human make easier or quicker decisions about what to do in business. And they've become so prevalent that we don't even use that term anymore. We just call it business software. Now we have patterns, we have a workflow engine, or we have rules engines, and we have various different ways to make features in our business applications. And a lot of these are expert systems helping the user make decisions quicker, or even suggesting decisions to make where the user can just hit approve. Or in a lot of cases, we just automate the decision making if it meets certain thresholds. Well, those are expert systems of the 90s that were previously called artificial intelligence. We don't even call it AI anymore because we have a better name. So push on into the future. A lot of the stuff that we call AI right now, once we productize it, once it becomes clear the use cases for a particular scenario, that's kind of normally what happens. We're going to give it a more specific, a better descriptive name, and it'll have its own name, and we'll cease to call it artificial intelligence because AI is kind of this umbrella term for the concept of, could we have yet another thing that requires a human? Could we have that new thing have just the computer do it, build a program to do it, which is the modern form of making a machine that can simulate it, which is the terminology back in 1956. So I want to show large language model local tooling, what you really want on your local computer. So I'm going to drag over. First of all, you want Ollama. Now, Ollama is really just a program that runs in the background, and just go to ollama.com. I'm not going to show you the download or it's just a next finish. But you open up in PowerShell and Ollama list. I have a number of large language models running locally, and I can say Ollama run, and I kind of like Llama 2. It's fast, it's easy, and it pops up. And what I'm also going to show you is my task manager, because it kind of uses some system resources. All right, so we run this, and with any model you download, you can download all the open source models with Ollama. I like asking, what can you do? Because every model is a little bit different, so you kind of have to learn about the different models. And of course, this one, it lists out a whole bunch of things, and play a game with me is one of the things it listed. So there it goes. Okay. All right, so it's pretty fast. Now look at the task manager on the right, and I'm going to ask it to generate 2,000 words of essay. Let's see if I can just get it start working. Okay, and on the right, you can see the CPU. It starts off, and the GPU. It goes back and forth between CPU and GPU. In order to start responding, it hits the GPU, and then for generation, just running the console window takes some CPU, and I'm doing other things on my computer as well. But if I were to ask, what is the hardest prompt for you? And sometimes it is very wordy, and I just want it to finish. Give me an example. And you can go through, and this is kind of the process for learning about a particular model, because they're all different. For instance, I'm gonna pop out of here, and you'll see another model is DeepSeek. So Ollama run DeepSeek R1. And this is the one that I can get to run on my computer. The DeepSeek, I think V1, it's so large, my hardware just can't run it. But while that's starting up, I'm going to talk about the hardware. So I happen to have a desktop computer. I also have, my laptop computer is a Surface Laptop Studio that comes with an NVIDIA RTX 4060. Which is not equivalent to a desktop 4060, but it has the CUDA engine, which is really important. Having a CUDA engine in your computer is essential for this local piloting. And so I've had a desktop computer for a long time, one of the Dell Alienware ones that I had for 5 years now. I went way overboard 5 years ago, but so it's still a great computer now. But I run on the AMD Radeon. I happen to have 3 regular monitors going and another USB monitor. And so what I did is, some time ago, I bought an RTX 3060, which is it's a more affordable because it's a couple generations back, but it has the CUDA engine, and I put the GPU in the spare PCIe slot. And by the way, with my laptop, I've gone down the research. You can get Thunderbolt or USB-C PCIe slots, and so you can actually add a video card to your laptop if you need to. But the 3060 or the older generations, they have the CUDA engine, and that allows you to run against a GPU instead of trying to slog through using your CPU. If you try to do this stuff, your CPU just hits 100%, just sits there and it's dog slow. That's just the way it's going to be. You need to get it into a CUDA engine, so you need CUDA cores, CUDA, and an NVIDIA GPU is going to get you that. AMD is working on that, and they have some decent options, but NVIDIA's got such a head start, and so I just popped this into a my extra PCIe slot. I don't even have any monitors plugged into it. The GPU literally is there just to do the processing. So DeepSeek, let's see. You know what? I'm going to ask, what is 2 plus 2? And notice I'm going to mix word plus numeral. And DeepSeek, it has a thinking. And so you have the think tag, and then it gives you a solution. So it's very different. Let's see. What is the capital of Texas? Okay, so this is called a reasoning model, and it has a little HTML think tag or XML think tag, and then a whole lot of thinking, and there's the think tag right about midway, and then step-by-step explanation. So some of these are very, very chatty. So let's go to LM Studio. By the way, Llama, it's going to be a little program in your system tray. I'm going to talk about the architecture, how it works later, but just things that you want to have locally on your computer. And I'm going to pull open LM Studio. This is another program. It's free. You just go to the website for LM Studio, go next, finish, and then you go over to models, and then you download a couple that'll fit. On my computer, I've tried to pull down this 5 billion parameter Quinn2. It's 397. Actually, that one works just fine. The much larger one gave me a problem. But you come in here, you select a model to load, and let's just ask that. What's the capital of France? And there it is. Okay. And I like to say, what is 2 plus 2? Just to see how verbose, instead of just giving me the number, it gives me a full sentence. So, but every model is a little bit different. But these are the tools you use to kind of learn about the model. Just like going to ai.azure.com, you can learn about the proprietary commercial models that are not open source, and the AI Foundry web application at ai.azure.com. That's your little playground to play around with the Azure OpenAI models there. But to do these things, these are the two tools you absolutely want to have running on your local computer. LM Studio right here. I mean, look, you have basically your own private chat GPT, and you can test things there. All right, let me put these away. Put that away, and that is local LM tooling. Okay, now what's actually running on our computer? And of course, if you're using it in the cloud, it's running in the cloud that way. But when you're using a LLM locally, which by the way, I showed the interaction with it in two different ways from two different UIs. One is a command line directly to a Llama console, and the other was through LLM Studio. But I have the large language models locally, and actually, one thing I didn't show you was where the files were, because those are some really big files, and I have a directory on my disk for. Let me see if I can pull that up real quick. And I need to move over to the right screen. Okay, I have a directory on disk, and the blobs I've just sorted by size. These are the actual files of the large language models. Now, the other directory with the manifest kind of tells you which file is which model, but my computer, it's kind of sluggish with this 19 gigabyte one, but all of the other ones are very usable just by putting in a RTX 3060 graphics card into my computer. So I can run a number of them. Now, some of these models are quite a bit larger. and you need beefier hardware, and that's just the reality. But this is kind of what it looks like. You just need some hard drive space, and so I have a D drive, which is a extra Samsung 2 terabyte SSD, and I kind of throw them on there, and that's what they look like on disk. So just want to show you. Now, this right here on the screen is the runtime architecture diagram, and I want to walk through things just to give you a parallel. So many of you, probably almost all of you, if you've done .NET development, you've also used SQL Server, and there is some really good parallels and some contrasts with SQL Server. So in SQL Server, and forget Azure SQL, but if you're on your developer workstation running totally locally, what's running on your computer? Well, somewhere on your disk is an MDF file that actually is the database. And it could be a really big file or it could be a small file. It's the data file for SQL Server. You don't have any code that literally goes and does a file.open on the path of that MDF file. You don't open that file directly. Instead, you have a different program that's running on your computer that's called the SQL Server engine. And SQL Server is a background process running, and that process has your mydatabase.mdf file actually open. And that process running exposes an API. And to get to it, to communicate to it from our .NET application, we have a connection string that has, localhost or 127.0.0.1, and there's the protocol there. And to use it, we don't do it anymore. We don't craft the query strings by hand. We use Entity Framework. We use a library. We used to use libraries like InHibernate, or sometimes we use Dapper in our ORMs, but Entity Framework is the most popular. And we have a library that crafts the magic string that, when sent over to SQL Server, it knows how to parse that string and say, oh, it's a select statement. I need to go and get some data from these few tables joined together. So we have a string that's crafted a certain way that makes SQL Server do something and then give us back information that then Entity Framework parses back again into our .NET objects in C#. Okay, so our application doesn't interact directly with those files. It goes through a running process called SQL Server. That is actually the same with the GPT technology that's running here. So let's move over to that. There is a model file. I showed you those gobbledygook SHA 256 file names, and that are 4 gigs and up. And there is a model file on the drive. We do not have any .NET code that does file.open on that file. Instead, we have a process that's running. It could be called Ollama. That's the most popular, and so you can call it a LLM server, which I think is probably the best name for it. And so instead, SQL Server, instead of a database server, you have the LLM server. That's Ollama. It's a process running in the background on the computer, and it has the file that's open, and then we know where it is. It's on the local computer, and we have a connection string to it, or an address to get to Ollama. And again, we don't craft the prompts directly to it. Instead, we use a library. And these libraries are in the Microsoft extensions libraries. I'm going to show you the Ollama Sharp. I'm going to show you Semantic Kernel, and a lot of work is being done on those. And I expect some new versions to be coming out, probably multiple versions, throughout the year, because they've had a pretty good release cadence. But we use a library, just like on database side, you use Entity Framework. We use the Microsoft Extensions AI libraries for our .NET code to call Ollama or any other LLM server, just like Entity Framework can call SQL Server locally, or Postgres or MySQL or any other database. So it's the same parallel, and we don't hand carve the prompt, the full prompt. We just use the library to craft the prompt, because I want to show you what a prompt actually looks like. What you type in ChatGPT or what you type in a text box, that is just a piece of a prompt. Okay, so this is what's running locally, and then so many large language models support the calling of tools, where there's extra things that need to be called. However, a LLM server is purely compute and purely read only. That's a difference. With SQL Server is read write. It can read to this mydatabase.mdf and it can write. The LLM server never writes to the model file. Those model files are they're read only. They are what they are. We do not modify them. We download them, we use them, we do not modify them. So an LLM server is purely compute. And so if you're using the open source models, there's actually probably over a dozen LLM hosting providers out on the internet to host it. And for the commercial models, the GPT-4o and the Claude and a whole list, certainly OpenAI hosts them, Microsoft hosts them, but also Anthropic hosts them. And so there's hosters of the commercial models, because this is just a compute need. So when you're deploying your application, you just need somebody to run an LLM server for you with a particular model that you need access to. And if you need the Llama 3.2 model, it actually doesn't matter who hosts it for you. Llama 3.2 is the same everywhere, just like GPT-4o, whatever name and version, it's going to be the same regardless of what hoster you choose. And some of these models can call tools. The LLM server doesn't call the tool for you, and certainly a file doesn't call it. But what it does is the interaction, and we'll see this, we recognize that we have to call a registered tool, and so that response goes back to Microsoft Extensions AI, and our application actually calls the tools. So this is where I want to actually run a run a demo for you on this. But before I, but yeah, I'm going to run the demo before I move on. Okay, so pulling over Visual Studio, I have 23 tests actually, and I'm going to run them in front of you just so you can see that they work. We have some of these tests that are going to Azure OpenAI, and I'm just hopping over to local Azure account, and I'm using a very small large language model. I'm using GPT-4o Mini, and I think maybe it charges me a few cents per day for just kind of running tests and doing iterative things, because it's such a small model that it's not expensive. With the large models, they're more expensive. But what you find is when using Microsoft Extensions AI and your actual .NET applications, the round trips and the number of tokens is a lot smaller than free-form conversations and asking it to process, large documents and things like that. But so our test suite typically takes 56 seconds to run because of the different things that we're doing. But I have a mix of Azure OpenAI targeted tests and a mix of Ollama tests. For simplicity in this presentation, I'm going to just illustrate the Ollama tests, and I have, all right, so they all pass. That's good. I'm going to go through the calling the tool with Ollama. Okay. Actually, first I'm going to show you the notion of chat history. Every interaction with your .NET application is, well, not every, a lot of them are going to use chat history. So chat history is just an object, and you can see, look, Microsoft extensions and Microsoft semantic kernel, and these libraries are a little bit of in flux. I think from what I've heard, and Stephen Tobe was on my Azure and DevOps podcast recently, and he shared with us a lot of great information about Microsoft Extensions AI, and they're put a lot of effort into that. And so that's going to be where you're going to use these things. But and semantic kernel is just part of that. If I want to ask the question, how old is Jeffrey's wife? There's no model that has that information, but there is information that you can feed to the interaction with the model through the chat history. And if I run these prompts in order and keep the history, Well, guess what? I've said that my name is Jeffrey. I've said Liana is Jeffrey's wife, and I've said she is 1 year older. So now, if I if I just run how old is Jeffrey's wife? Let's do that. Can't do it. It's going to fail, right? Yep, unknown, and I expect it to be 46. Let's run them all, and it's going to run them in sequence. We have chat history in the base class, LLM tester base, which is just going to basically be shared. And how old is Jeffrey's wife is the last one, although it shows it here. Okay, those pass because I'm doing an assertion that the result value should be expected. If this syntax looks a little bit wonky, this is a very standard test automation with in-unit where you have multiple test cases and you have attributes specifying variables and passing them in here. Okay, and LLM tester base, if I control B with my resharper, control B into chat history, you can see LLM tester base. I'm declaring that as a class level variable to be chat history. And this is where we just set up some of the stuff that would go in your program CS to add OLAMA chat completion and pull out some environment variables to know where to go for it. That's it. So that our test classes are pretty simple. Okay, so that's one scenario where your chat history, oftentimes you're going to need, in order to leverage a LLM, you're going to have to do a sequence of prompts and round trips. So you want to keep that chat history. All right, let's go to tools because this is so important. If I want to say, if somewhere in my application it becomes useful to know how old grandpa is, then I should be able to um, figure out how to do that. But there's no like who the heck is grandpa? I don't know how old grandpa is. But what I've done is by setting function choice behavior auto and by having the import, again this would be in program CS or in the service provider code. I'm importing a plugin from type demographics kernel function. Let me control B into this just so you can see where that is. And I have a method that's annotated with kernel function and give it a description in English just to help out. But kernel function, and this will be detected and get person age given a name. And if it's grandpa, then 81. Okay. Now, a kernel function or a LLM tool, it's just a C# class. You can make it arbitrarily do anything. And so obviously, a tool that you're going to want in a lot of scenarios is something where it can be called and it runs a query against your database. I mean, or calls into a web service of another component of your system because there's information that's locked in all the different parts of your system that no LLM knows how to get to. And so you need to create these seams. And with an LLM, it's called, the term is tool, Tool. And with Microsoft extensions AI, this is the method right now for registering tools. And there's a whole lot of LLMs that support tools. And so let's run this. And if you just go to Chat GPT and say, how old is grandpa, respond with a single value, it doesn't know what you, and I also gave it some hints. Respond with a single value with no punctuation. Why? Because I want to be able to make an assertion here that it should be 81. I want 81 to be the response. I don't want a whole sentence. Grandpa is currently 81 years old. Are you thinking of getting him a birthday present this year? Some of these LLMs respond with a lot of fluff. Where in programming, no. I just want exact values, and so adding different instruction types and through the system messages versus user messages, you can add instructions like this. I'm not going to go into that level of detail. But let's go to calling the kernel twice. So if I want to ask, is grandpa's age older than Liana's age? Well, now I have to know Liana's age and I have to know grandpa's age. But let's go ahead and run this because I want to show you what I'm doing. Now, um, I have added um, the tracing. If I go back to my base class where I set this up, I am adding logging, just so you know where this is coming from. I'm adding console logging at the trace level. Okay, I wanted to do that because so I could show you what is actually happening. And so I'm going to expand this up so we can see. And so inside, what's happening is I invoked the chat client, and as a role of user, I asked, is Grandpa's age older than Liana's age? That's what I did. Okay, and the response, because every time you send a prompt, you're going to get a response, and the response back from role assistant means this is the response. And by the way, um, remember when I said, just like in Entity Framework, we don't craft the full SQL prompt or the SQL query anymore. This is actually the LLM prompt for the Llama 3.2 model. Does anybody want to hand roll that? No. Okay. So it's just like Entity Framework. We're going to be using these libraries to put together the prompt for us. I mean, think about it. Nobody handcrafts an HTTP call. Nobody wants to hand roll the string that is an HTTP request or parse back the string that is an HTTP response. We use libraries to do that and make our lives easier. Same thing here. Okay. But the response here was not what the age was. The response was, I need you to make a tool call for me. And I actually need you to call tool call. So when you say, oh, the LLM is going to needs to call a tool or needs to call two tools, that's actually factually incorrect. LLMs and LLM servers like Olama do not call tools. They can't. I mean, the tool is going to be your software system. And if the LLM is hosted in Azure OpenAI, there's no firewall tunnel from wherever that is to some private component of your system or your database. No, no. So LLMs do not call tools. Instead, they are going to respond with a request for you to call the tool and tell them what the value was. But the Microsoft Extensions AI libraries, they just do that for us, save us a lot of time. So semantic kernel being part of Microsoft Extensions AI, what happens next? Well, oh, before I do that, this round trip took 223 tokens. I'll come back to that. All right, so what happens then? Well, we are, and this, look, Microsoft Extensions AI, what's happening inside the library, even before handing back my code, the call stack, okay, I need to call this function with grandpa. Okay, I'm invoking, name grandpa. Okay, it succeeded. The result was 81, and this is how long it took. And now I need to do, okay, what am I doing? I'm invoking the tool, Liana, invoking. Here's the argument, succeeded. Response was 46. Here's how long it took. Great. Now the library has the tools, and so the library automatically is going to send another prompt to my LLM and is going to include the history. So the first thing that happened, again, every time you prompt, you are sending the full history of everything that the model needs to remember, because the model's not going to remember what you did. You have to send it back again. So we're sending the first prompt, is grandpa's age older than Liana's? Then we're reminding it, sending it that, hey, these tools were requested, and we did that for you. And here are, see, role equals tool. These are the results of calling the tools. So now can you do it? So let's scroll down a little bit. And so now the role of assistant, what's the response? The response is yes. And that's what we wanted. Is grandpa's age older than Liana's age? The response was yes. And in our test, we are asserting that the response should be yes. And there can be multiple tokens that come back. And so in this case, we just say, well, I want one token, and the first token needs to be yes in order for it to succeed. But if we go down, we can see the total token count for this round trip was 159. We go back up, the previous round trip was 223. So 159 plus 223 is the number of tokens that it took us to get this interaction going. And so when you log and count up the tokens, this is going to help you budget, because Azure OpenAI and all the rest, they basically bill you by number of tokens. So you need to have these automated tests for the different things that you're doing and run it locally, and thereby you can project for each call, you can project how many tokens, thereby how many dollars and cents, and then you can extrapolate with how many users, how many times those features of the software are going to be using, and you can create your LLM server budget. Okay, so that's all I'm going to go into there. And this is available on my GitHub, github.com/Jeffrey Palermo. AI Semantic Kernel is the name of the repository, and it has 23 tests with all kinds of different scenarios, so that you can see examples of how to actually write automated test cases that make use of an LLM. Because, and by the way, if your application just needs a chatbot, there's actually plenty of commercial providers now where you don't even have to write any code. They'll just give you a snippet of HTML, just like so many other components. Drop it into the UI of a web application, and you've got a chatbot, and you can even give it access to your knowledge base. I mean, the commercial offerings are actually pretty impressive, and I expect that more commercial offerings are gonna be popping up. So you're not going to have to write simple AI integrations. What the code that you're going to write are the things where no commercial provider could possibly provide that to you. Why? Because in order to do it, it requires interaction with private components of your system that no commercial provider would be able to do. All right. So let me pull this away. And coming back, just reminding, this is what's actually running. So the .NET application actually contained the code that were the tools. And the Microsoft Extensions AI libraries, well, they are just dependencies, and they are running inside the memory space of my .NET application. And so if the tool does end up calling out to some other web service or calling to my own SQL Server database, well, that's just my code that's calling a particular part of my application. Olama cannot call out to anything, and certainly the model file can't call out to anything. So, in some ways, Olama and all these LLM servers are simpler than our SQL Server because it's read only. All right. That's very important to understand what the architecture of it actually is. And if I'm using it in Azure OpenAI, it's just a compute resource, okay? Because Azure OpenAI, with Olama, we have access to all these open source models, but we can't download GPT-4o. We can't download Claude. Those are not open source models, and so we have to go to a hosting provider that, like Azure OpenAI, to get access to them. But when we do, we're just round tripping to make use of that model. Okay, now I want to turn the attention for the rest of the talk to AI-driven development. And some have called it prompt-driven development, but that seems to be a clunky word for me. And who knows what word is going to stick. But let me set the stage for you. A few months back, I interviewed Jeff Sutherland on the Azure and DevOps podcast, and in the Navy in the 70s, he related how he kind of formulated the ideas of what would later become Scrum. And then, of course, in the 90s, he partnered up with Ken Schwaber, and they created kind of the Scrum organizations that were huge at the beginning of the Agile movement after the Manifesto for Agile Software Development. And of course, everybody knows the word Scrum today. But he talked about a term that I hadn't heard before, and he's talking about the term extreme agile. And he's saying by 2030, teams will need to be 30 to 100 times faster than they are now. And then, a little bit of futuristic thinking, and he said that AI is a part of that. and there's going to be more programmers than ever. I don't think programmers are actually going to be um, replaced by machines, because programming is largely an idea of design. It's like figuring out what to do. Once we know exactly what we want to do, well, now we have a set of mechanics to automate. But if you look at the progression over the last probably 30 years, and a lot of you probably weren't doing any development in the 90s, but let me just set the stage. In the 90s, um, at the beginning of the 90s, code was kind of written just with glorified text editors, and you typed out every character. But by the end of the 1990s, there was this thing called IntelliSense, where you hit the dot character, and there were suggestions for you know for methods and properties and things that you could use. That was huge. And then in the early 2000s, JetBrains was really pushing the envelope, and it wasn't just IntelliSense, it was um, it was variable suggestion and snippet suggestions, and I could hit a I could hit a hotkey in 2003. I could hit a hotkey, and I could generate an entire for loop or an entire switch statement in 2003. And fast forward to today, that type of generation is old hat. It's not interesting. And we've seen with Copilot that not only can we continue to those things, but we can generate entire functions, entire methods, entire classes. And I'm going to show you Copilot edits. If you haven't seen it, we can generate um, multiple changes in multiple files. And so that progression where the tooling can generate larger and larger changes once it's very clear what to do, that seems to be on steroids right now. So imagine, um, well, let me just move to the demo. Let me pull over this application. This is using the file new project. I just want to show you because this is out there, but a lot of people don't know about it. The AI chat web app project template. It literally is a project template, but you have to install it into your Visual Studio. So you might want to do that because it shows you the RAG pattern with all the mix of libraries, and it's actually a really good sample. So just do a search for AI chat web app project template, install it in your Visual Studio, and just do next, next, finish. Now, you want to have Olama running locally and whatnot, but essentially, that's all I did. The README file. That's all I did over here. This is just create a brand new application, and then I'm gonna hit Control F5 and run it. I haven't made any changes. This is um, literally just the out of the box. And out of the box, it gives us this little chat interface. Tell me about the GPS watch. And it is running right here. Yeah. So you can see when it started up, it actually ingested an emergency survival kit PDF, GPS watch PDF, and these PDFs were in it. And so this shows that I can have some documents with my own proprietary information, and then answer questions about it. Okay, so let me pull this off to the side because that's not the interesting part. And by the way, the www data GPS watch. So if I don't want to open it, but it's a PDF, and I just asked about the watch. Okay, so GitHub Copilot chat, there's the edits. So there's the two modes. There's the new thread where you can chat with Copilot, and then there's edits. So I didn't have to type this out. What I happen to know that this user interface right here happens to be chat.razor. Okay. And so I'm going to ask it if I do components, pages, chat.razor. Okay, I'm gonna say, starting at chat.razor, give it a little bit of help. Add a feature with a counter on the screen. Increment the counter every time I send a message as a prompt. Update the counter. I'm a little bit verbose, and I'm going to use Claude Sonnet. So, and some of this is non-deterministic. This is very new, but it seems to be able to analyze and figure out what to do more times than it fails. And so, what I'm not telling you right now is that you can just rely on this for everything because it's new tooling. But what I am calling out is that this is moving really fast and it's becoming real. So um, it creates a plan for what it's going to do. Add a new state variable, create a new visual counter, increment the counter, and then reset the counter, style the counter. Okay. All right. So my hands are not on the keyboard. It's kind of going through and it's figuring out where to put things. And then I'll look at it. If it's not going in the right direction, or if it's not code anywhere near what I would have done, I just reject it. But for the sake of the demo, I'm gonna accept all, and then I'm going to close the application. And the only thing that I'm going to do here is I'm going to hit Control F5 again. So I have red. We'll see if that's a compile error or not. Sometimes the tooling just doesn't refresh. Okay, application is starting up. Its ingestion is up to date. And okay, browser, it came back up on the browser, and we can see this is new. It's not styled the way I would do it, but let's see what happens. Tell me about the GPS watch. Okay, immediately the counter updated to 1, and the first message when you start. Okay, and how about the survival kit? Oh, I have to go back. Message. See. Well, I wonder if. Okay. And how heavy is the watch? I scroll back. Message sent 3. I can just say thank you. And scroll back up 4. So it's working. It's functionally working. Okay. Now, that's not really a cool feature, but what is? Just think about the implications of this. I am giving it some hints. I can do pound, and there's all my files, and because I know how this is being implemented under the covers, there are custom tools being registered that can inspect the files, can inspect the solution structure. There are tools that can drive the UI of Visual Studio to make edits and open up files and do all these things. And so there's a whole set of tools that are being registered with the actually with Microsoft Extensions AI. And so when Claude Sonnet sees, oh, I can do all these tools, then it comes up with a plan and generates a set of tasks. And in this case, it only wanted to modify one file. And so fast forward. Now, this is a demo. It can do small things now. But fast forward 2.5 years, because 2.5 years ago, we were all being amazed by ChatGPT. And it could do some things, but we were quickly disillusioned by how much hallucination, how much it got things wrong, how stupid it actually was, that it wasn't actually any actual intelligence. It was purely artificial. But 2.5 years from that initial ChatGPT release, how many situations and scenarios have really proven out with these large language models and the GPT algorithms? Quite a lot. So 2.5 years from now,
Hello?
what's that? 2.5 years from now, I expect this to be where we are saving a lot of time. I'm looking at. I think this year, because they are releasing this thing at such a fast cadence. GPT GitHub Copilot, where I'll be able to take something that would have taken me a full week just to kind of get it working and do it in a day, or something that would have taken me all day and have it implemented into an hour. Now, I'm not talking about generating code that I hate, that is trash and that is hard to maintain. If it does that, I want to throw it away. I'm talking about generating code that I'm happy with. I'm generating code that I would have done it that way anyway. After all, the way I'm driving it kind of guides it to what I want to happen. But if we come back to Jeff Sutherland's assertion on extreme agile, um, I, for one, am always in a search of how to get some of the repetitive and time consuming things out of the software engineering workflow. And this right here, a little bit of encouragement. This is going to make all of us more productive, and it'll help us interpret some of the futurists, like the CEO of Anthropic and even Mark Zuckerberg from Facebook. They've said, hey, within 5 years or some period of time down the road, 80% of new code is going to be written by AI. Now, if you just hand wave 80% is going to be written by, then of course some people say, oh, so we won't need programmers anymore. Well, hold on. We If we're using these tools, then I, as a software engineer, can get done in an hour what might have taken me all day to do. Now, technically, did I have some AI tool typing out all of the characters of all of the code? Yes. So is somebody going to come back and say, see, 80% of that code was written by AI? Okay, but you know what? 100% of these pull requests came from me because I am delivering that software feature. I happen to be using better tools. And for my entire career, I started programming in 1997. For my entire career, I've always wanted to use the best and most powerful tools. Well, I'm telling you that this next era of tools is a huge jump forward in just the power of the tools available to us. And I don't see anything in this, by the way, that's on track to be able to just kind of do it automatically without me deciding how it should be done. So I don't think software engineers have anything to worry about, but we are going to be so much more productive and get so much more done. And as I close, I want to talk about establishing patterns early, because anybody that's tried GitHub Copilot and AI-driven development will be this on steroids. If you have, it is going to give you more of the same type of code that you have in your code base. It is going to conform to the patterns that you have established. If it's nothing but spaghetti code and totally disorganized, well, you're just going to get more of that, because there's no actual intelligence. AI doesn't mean actual intelligence. There's no actual intelligence in GitHub Copilot. It's artificial intelligence. It's going to look at what you have and it's going to try to pattern match and kind of be the ultimate chameleon coder. So architecture skills in the AI driven development era are so important. You have to decide what design patterns, you have to decide what libraries, what interaction patterns between components, and you have to establish them very clearly, clear layers, clear namespaces, clear abstractions, clear pattern usage, clear library usages, and then the algorithms with Copilot, GitHub Copilot, it'll be absolutely clear of how you want the code to be implemented, because it's going to pattern match for you. If you don't have those patterns implemented into your code base, then GitHub Copilot is not going to be as useful to you. So the first time you have a new pattern into your code base, you're going to have to hand code that, because you're using actual creativity, and you're going to have to hand code it, make sure. And then when you have the second and the third of that type of thing, well, now Copilot has something to pattern match against. And you like reports are the no-brainer. You'll be able, once you have the pattern for generating some type of report or screen, or a grid that shows some information, you'll be able to just jam those out, because it's just rinse and repeat. if you had a younger, a junior developer on your team, you thought, what kind of things would I give to that junior developer? Because the patterns are established. It's not, you don't have to, do the architecture for that type of feature. Okay, well, same thing. You can use Copilot and just give it a prompt and have it cram out. So on your Kanban board, you need to have specific design columns ahead of your development column. All right, I'm just going to gonna skip this particular slide, and as we get to the end, I'll end it on the offer from my latest book, and and pass it back, or if there's any open questions. And I really appreciate having the opportunity to speak here today.
Excellent. Thank you, Jeff. Does anyone have any questions or comments for Jeff? And if not, I have a question for you.
Yes, sir.
What has been your experience, if any, with CUDA versus ML.NET or DirectML rather?
So on my hardware, I think I've only used CUDA. Well, I've accidentally used the CPU runtime, which is dog slow, but I've only used CUDA. So I haven't done hardware research. I got the NVIDIA card just so I could run things locally, and then from there I was happy. And so from my understanding, as long as you have some hardware avenue to run these things locally, you'll probably be good.
Gotcha. Okay. Marshall, did you have a question?
I downloaded the app for GoToMeeting, and I still get the green purple separation, and I can't get the QR code scanned. So if you could put the links in the chat, that would be helpful.
Yeah, and I got it as well. I'll be posting that in the chat and then making a blog post about all the links once we're done.
Awesome.
But yeah, I can take care of that.
Is there any commercial, the question for the speaker, is there any commercial feedback from customers that ask you for software, whether they care or insist that you do or don't use AI to generate code?
Yes, every single customer is asking questions just because it's so new, and there's a couple categories. Certainly, there's a category of worry because they've heard, there's these public stories of somebody taking entire documents and just dumping it into Chat GPT, which there's no contract with anybody or no confidentiality obligation of Chat GPT if you literally dump in documents. And so there is that worry. It's like, whoa, hold on, nope. If you're any AI needs to be explicitly approved by our, security officer and legal. So there are that category. And then, so for ourselves, we have guidance for our own consultants that is just like anything. Hey, don't email to a stranger something confidential. Don't, paste into some random web service anything that's confidential. It's the same stuff. It just happens to be new opportunities to do something that would violate that. But with the Copilot line of tools, because they are under the existing Microsoft agreement and contracts, that is the one avenue where we're automatically covered by being Microsoft customers and using Azure. And so that's the one avenue where legally and from a documentation and a compliance standpoint, there's no barriers there. So we have to educate our customers in that, but certainly different customers are on different parts of the continuum with maybe what they might be afraid of, or somebody did something stupid in their organization, and so now they're gun shy because somebody made a really bad mistake. But other customers are asking, how should I be using this? I've heard that AI can do all this stuff. So do I need to have AI writing my software instead of my programmers? There's just questions like that because there's all these fantastical statements being generated out there in the media. And so we end up doing a lot of education that way. And I think that's going to be the case in any fast moving era. There's going to be the case where, hey, what's reality right now? What's the future I need to plan for? But then, of course, pull back to what's the reality right now. and it's moving so fast. It's exciting, but at the same time, it's a challenge to keep up.
Thank you.
All right, excellent. Jeff, great presentation as always. Appreciate your time and taking time out of your busy day to join us. And always good to see you present.
You as well. It's my pleasure indeed. Thanks for the invite.
All right. Take care, Jeff, and we'll see you soon.